You ever wonder how these huge, massive teams build really complex software without everything just descending into total chaos? Well, the secret, it turns out, is a shared blueprint. So today, we're going to decode UML. That's the Unified Modeling Language, and see how it acts as the master plan for pretty much any software project out there. Okay, so think about it like this. You'd never, ever try to build a house without a super detailed blueprint, right? I mean, that would be crazy. You've got to know exactly where the walls go, where the plumbing runs, all of it. Well, guess what? Software is exactly the same. Without that solid plan, even the simplest project is basically set up to fail from the get-go. Right, so what happens when you try to skip that step? Just picture it. You've got this team of brilliant engineers, but every single one of them has a slightly different idea of what they're building. It's an absolute recipe for disaster, Just tons of confusion, wasted effort, and some really, really expensive mistakes later on. And this is the exact problem UML was born to solve. It literally takes a project from that tangled, chaotic mess of miscommunication and turns it into something with total clarity, a common visual language that everyone can understand. So here's the most important part. UML is that common language. It's a standardized set of diagrams that lets everybody, I'm talking developers, project managers, even the clients, look at the same page and finally understand the big picture together. Okay, so how does UML actually pull this off? How does it build this complete picture? Well, it's not just one single diagram. Not at all. It's a whole collection. And a really powerful way to organize all of them is with a framework known as the 4+1 architectural views. The whole point of the 4+1 views is to make sure that every single perspective is covered. You're looking at the system from all the different angles of everyone involved. That way, no critical details get missed. It's kind of like a safety net for your design. All right, first up, we have the logical view. Now, this one is all about the end user. It answers the big question, what does the system actually do for them? It's all about functionality, and you'll often see things like class diagrams here to show the system's basic structure. Next, we've got the process view. This one dives deep into how the system behaves when it's actually running. Think about it. How does it handle a bunch of tasks at once? Is it going to be fast? Can it scale up? This view tackles those crucial things like performance and concurrency, and you'll often see activity diagrams used for this. Okay, now for the programmer side of things, we have the development view. This is all about managing the software itself. It shows how the code is broken down and organized into neat little packages and modules. This makes the whole code base way easier to navigate and maintain. You'll usually see package diagrams for this. Then there's the physical view. This is really the system engineer's turf. It's where the rubber meets the road. It shows how all those software components are actually deployed and connected on real physical hardware. You'd use a deployment diagram to map this out. It basically answers, where is this code actually going to live and run in the real world? And finally, that brings us to the +1. This is the context view. Think of it as the glue that holds everything together. It's the unifying big picture. You'll see use case diagrams here a lot. It basically describes who or what is interacting with our system from the outside, whether it's a person or another computer system. It's what ties all those other 4 views into one coherent story. Okay, I know what you might be thinking right now. This sounds like a ton of diagrams to create and keep updated, especially if we're moving fast. And you know what? You'd be absolutely right if we were still doing things the old-fashioned way. So let's check out a much more modern solution. See, the big problem with those old drag-and-drop diagram tools is they just can't keep up. In a modern, agile world, things are changing constantly. Trying to keep those visual diagrams in sync becomes, well, incredibly cumbersome is the perfect way to put it. It's just a huge pain. And this is where a tool called plantUML comes in and is a total game changer, seriously. Imagine this. Instead of messing around with drawing boxes and dragging arrows, you just write a few lines of simple text, just like you'd write code. This means your diagrams can live right there with your source code. You can track changes in them and update them with almost no effort. How cool is that? And here's what that actually looks like. It's just a few simple lines of text. That's it. That's all you need to define the entire structure of your diagram. No dragging, no dropping, no fuss. Just clear, simple text that says exactly what you want to build. And now for the magic trick. With just one command, bam! That simple text instantly turns into a clean, professional, perfectly formatted UML diagram. All that manual work of lining things up and making it look pretty, gone. It just does it for you. So, you're probably wondering, how can I get started with this? Well, it's honestly way easier than you think. Let me walk you through how to create your very first diagram right now, and we'll use a super popular editor, VS Code. It's really just 3 simple steps. 1. You install the plantUML extension. 2. You make a new file that ends in .plantUML and just start writing. And 3. You hit a quick hotkey. That's Option+D on a Mac or Alt+D on Windows, and you can watch your diagram pop up right away. And just to make this totally foolproof for you, here are a couple of quick setup tips. First, make sure you get the plantUML extension by a user named Jebs. The most important setting is to change render to remote, and then just pop in the official plantul.com server URL. Once you do that, you're all set, ready to go. All right, so let's wrap this up and really focus on the big takeaway here. Why does any of this matter? Why is mastering this visual language so important for whatever you're building next? At the end of the day, it's all about this, UML. Especially when you use it with a modern tool like plantUML, takes all those abstract lines of code and complicated ideas and turns them into a shared physical blueprint that everyone can see and agree on. It is, hands down, the best way to stop those expensive misunderstandings before they start and make sure your entire team is on the same page building the exact same thing. Look, getting good at this isn't just about drawing pretty pictures. It's about being able to communicate really complex ideas with absolute total clarity. We've gone over the what, the why, and even the how. So now, your project's blueprint is just waiting to be created. The only real question left is, what are you going to build first?